So for problem 2, we've got a couple buying a house who borrows $325,000 for 30 years at 4.6% interest. And you know what I'm going to say. I feel bad for these people because a 30-year loan is awful. Try to get a 15-year loan if you can, or buy a cheaper house. So we have an initial value in this loan of $325,000. We don't know what their monthly payments are going to be. The interest rate is 4.6%. And it's compounded monthly for 30 years. So our R over M is going to be 0.046 over 12. Let's check and see if that comes out even. Nope, so I got to leave it as a fraction. And then MT is going to be 12 times 30, so 360. And we can go ahead and swing that into our formula. So we got 325,000 equals R, which we don't know, times 1 minus 1 plus 0.046 over 12 to the negative 360 over 0.046 over 12. And thank goodness for Wolfram, because I would hate to do this by hand. So let's get into Wolfram. We are going to be using a present value of annuity for this because this is a loan, and so the amount in the account will be going down over time, hopefully. So present value of an annuity for this one, we have 325,000 equals, we don't know what R is, and that is 0.046 over 12. N is going to be 360. And then again, 0.046 over 12. So got to divide. We get 325,000 divided by 195,067. Is $1,666.09. So the monthly payment will be $1,666.09. That's actually cheaper than I thought it was going to be. So let's see what we've got next for this couple. How much will the couple pay in interest? And so to figure that out, we need to find out the total payoff and then subtract how much they bought the house for. So total payoff is going to be $1,666.09 times 12 months times 30 years. And that's going to be a lot. So 1,666.09 times 12 times 30. It's going to be $599,000. 792.40. So they're paying for this house almost twice. And so total payoff is $599,792.40. Total interest is going to be that amount minus 325. And I'm going to do it on my calculator because I don't want to make a silly mistake. So if I subtract the purchase price of the house, the $325,000, I get $274,000. $792.40. So we can see that the amount of interest there is almost as much as the original purchase price of the house. So again, they are going to pay for this house almost twice by doing this. And so if the couple were to pay an additional $100 per month toward the cost of the home, how much sooner would the house be paid off? How much would this save them in interest? And is paying the additional $100 worth doing? So let's investigate this for this couple. We've got our SERM 10. And so the purchase price of the house is still $325,000. The payment is going to add $100, so we're going to go 176,609. The rate is still going to be 4.6%. 12 months, 30 years. Well, no, we don't know the time, do we? Because we're going to pay more, so it's going to be paying it off faster. So we're not sure about the time. So our R over M is going to be still 0.046 over 12. That doesn't come out even, so I'm going to leave it like that. And our MT is going to be 12T. So swinging it in our formula over here. We're going to have 325,000 is equal to 1,766.09 times 1 minus 1 plus 0.046 over 12 to the negative 12t over 0.046 over 12. So I can probably reuse quite a lot of my formula from Wolfram earlier, so I'm going to leave it there. So my R is going to be 1766.09. And instead of 360 payments, we don't know how many there's going to be, so that's 12t. And we get 26.62 years, and so this saves them about 3.5 years of payments on their loan. So what's the question here? How much sooner would the house be paid off? So for part C, the house would be paid off about 3.5 years sooner. And how much in interest would doing this save the couple? So to figure that out, we need to figure out the total payoff. And so total payoff is going to be the payment times 12 months in a year times 26.6205 years. So in the calculator here on the side, I'm going to run that. And we get 564. 170.39. That's still a huge amount of money. So total payoff is less now. It's $564,170.39. Total interest is just that amount, minus 325,000. So total interest this time is 239. $170.39. Yikes. Still a huge amount of interest. Is paying the additional $100 a month worth doing? It's always worth making extra payments if you can afford them. Is really, but there's nothing to write home about here, right? Like, it's not a huge difference in savings. It saves them about $35,000, which is not something to sneeze at, but not tremendous savings either. So my answer would be anytime, any additional payments are worth it. if you can afford it. So for number 2, I think that's we put that puppy to bed. There's number 2. I hope this is helpful.